welcome everyone. So my name is Brendan Hassett. I'm a professor of mathematics here at Brown, and I'm also the director of ICERM. ICERM is the Institute for Computational and Experimental Research in Mathematics. We're supported by the Division of Mathematical Sciences of the National Science Foundation. And most of what we do is to encourage mathematical research, the discovery of new mathematical ideas. Our niche is aspects of mathematics that you can understand by doing computer experiments, and also algorithms and programs, computational results that come out of mathematical work. We also get support from the Simons Foundation, from the National Security Agencies, departmental supporters, and individuals who donate to us. We're part of Brown University. We're also interested in how mathematics and computation can have impacts on the wider world. And so the lecture today really fits under that heading. So we're very pleased to have Jonathan Mattingly from Duke to speak today. So Jonathan Mattingly comes from Charlotte. He graduated from the North Carolina School of Science and Mathematics. He continued his studies at Yale, École Normale Supérieure at Lyon, and Princeton. Since 2003, he's been a professor at Duke, and he's currently the James B. Duke Professor of Mathematics and Statistics. He's gotten a huge number of awards, a Career Award, a Presidential Young Investigator Award, a Sloan Fellowship, and he's fellows of many professional societies. We're very grateful at ICERM that he's also on our board of trustees, and so he advises us on strategic issues and programming directions, and so we're very happy to have his advice. So as a scholar, he's incredibly well known among mathematicians for his work on random approaches to partial differential equations. So he is one of the world's leading experts in sort of organic approaches to two-dimensional Navier-Stokes equations, which those of us who are mathematicians get really excited about. In fact, his work was cited in the Fields Medal that was received by Martin Heyer a few years ago. And so it's some of the strongest work out there. So he is definitely a card-carrying pure mathematician. But well, that will be another lecture to have him talk about that. Today, we're going to focus on other work that he's done to try to understand and quantify gerrymandering. And so he's been very active in this. He was involved in the Common Cause v. Rucho case, which went to the United States Supreme Court. And he's developed some mathematical theories and approaches to understanding the redistricting problem that have been influential in the wider world, but also have inspired a lot of mathematicians to get involved with these important questions. So he's going to speak on quantifying and understanding gerrymandering. Jonathan, please take it away. Thank you.
All right. Well, I'm afraid the best part of the talk may be over already. Thank you, Brendan. That was very kind of you. You didn't mention my biggest claim to fame. Maybe I'm not supposed to mention that. I was your college roommate. So it's nice to be here. So thank you very much for—
There's no nepotism here.
And no. Maybe I shouldn't have said that. All right. Anyway, it seems like I'll never have a chance to say something like that again. So anyway, it's very nice to be here, or not be here, unfortunately. But what I'm going to tell you about is a project that really started as an intellectual curiosity between me and an undergraduate student at Duke, and then really grew over time into something much bigger. And I encourage you to stay around for the discussion later. We have a really great panel, in particular, including this work has been a conversation between me and a number of lawyers. They've taught me a lot, and I've tried to convince them of stuff, sometimes successfully. And this work is much better because of that conversation. And one of them is in the panel later, so I encourage you to hang out if you can. And also, I'll say that this is supposed to be kind of a general high-level introduction to what I'm talking about. If you're a mathematician interested in some of the more technical details, there's a second talk tomorrow that I'm happy that at Brown that Brendan said he'll put the link in the chat. So please go ahead and hear it. So this is a joint work with Greg Hirschlag and some other members of my team at Duke. And well, let's get going. So we hear a lot about gerrymandering. It's all over the news. There's a random sampling of quotes. And, so despite these titles, I would submit that we really don't completely understand what it means sometimes. And that's part of what this lecture is about. And we also hear about it in the courts because, in the news because it's been in the courts a lot in the last decade. You can have various comments on why it's been in the news a lot in the last decade, but it might be a lot to do with the fact that we've reached a moment where our ability to process data and analyze things has really allowed us to be much more surgical, make much more surgical strikes in gerrymandering. And I put up a bunch of court briefs and court documents. One point about all of these court documents, I was involved in some of them, but some of them other mathematicians were involved in, but all of these documents had mathematicians involved. That's an interesting point. So this is actually the stuff that my team has worked on, but let's get straight to the question. So what is gerrymandering? So when I say this to people, they often start off with this definition. They say, well, you know, I live in this state like North Carolina or Maryland, and in the last congressional election, or in 2012 in this case, you know, the Democrats got 50% of the votes, just over 50%, and they didn't get 50% of the seats. Something's clearly wrong. Or in Maryland, you know, they got 63% of the votes, the Democrats, but the Democrats got much more. So here I've now put up the number of seats that they got. So in North Carolina in that election, the Democrats got 31% of the seats. And in Maryland, the Democrats got 87% of the seats, even though they had, you can see the statewide votes count. So people are often reacting to this fact and they say something is wrong. This is not the way it should be. But I want to remind everyone that that's not our political system. We don't live in a proportional representation system, despite what various members of various courts have said at various times. I mean, it's not, we don't live, that's not our system. So to use that as a foil somehow as to what gerrymandering is I think is incorrect. The other thing people often say is that it's when you have strange looking districts. They look at, so on the right here, you see the districts that we use in North Carolina. I'm sorry, we're in Maryland. I mean, I'm in North Carolina. I have a North Carolina centric view, but I think it's interesting because you can tell a rather complete story just thinking about North Carolina. I'm sure we'll hear about Rhode Island in a little bit when from the representatives from Common Cause. But I will say that mostly I'm going to talk about North Carolina just because that's where my work has been focused largely. So on the right, we have the North Carolina districts used in the 2012 election. And on the left, we have the North Carolina districts used in the 2016 elections, after the first ones were declared a racial gerrymander and thrown out as unconstitutional. But what I can tell you is that they are politically identical. From a political point of view of their effect, they actually lead to pretty much the same political results, even though they look completely different. So a thing I want you to take away also is, one, it's not about proportional representation, and two, it's not about funny looking districts. Getting rid of funny looking districts doesn't solve the gerrymandering problem. In fact, here's the districts that we're going to use in 2012 in 2020 in North Carolina. And, you know, if we're going to play which of these is not like the other, I think you would agree that the 2012 one looks different and the 2016 and 2020 ones look very similar maybe, but they actually act very differently. And that's part of the story I want to tell you. What do I mean by that? So every talk in gerrymandering has to have this, this dragon here, this salamander, if you will, this gerrymander, in fact. That's a political cartoon from the Boston Gazette, just north of ICERM in Boston from 1812. And it was Governor Gerry redistricting some state districts in a way that favored his party. So what is the definition of gerrymandering often given? Is to manipulate boundaries of districts to favor one party, partisan gerrymandering, or class, race often, racial gerrymandering, or to change the outcome. So somehow in this definition, I've read it out, I put two words in red. And that's because part of this definition presupposes that you knew what happened otherwise. Somebody changed the outcome. You knew what would have happened otherwise. And that's a really hard thing to get your head around. I mean, except that's why people tend to go to proportional statements about proportional representation. You know, the fact, but our system isn't proportional. So to use that as what you're going to compare to is I think, going in the wrong direction. All right. So Brendan, by the way, please feel free to interrupt me, as I said, you know, if anyone has a question. So I'll just keep going. So kind of central to the way I think about what is gerrymandering is the question of what would have happened without political agendas in an election. Okay. So here we have the great state of North Carolina, as it's called. And here, each of these little subdivisions are precincts. So this is the level at which votes are reported. So we'll have a vote count in each of these precincts. You know, there's thousands of little precincts. And this is where I'm sitting actually right now, more or less. It's not actually where my house is, but that's Durham, North Carolina. All right, so in the middle of the state there. And these were the districts used in the 2016 congressional election. So we have 13 representatives in North Carolina. So the state is broken up into 13 congressional districts, and these are the ones that were used. And then we hold an election and people vote. Here's the percentage Democrat versus Republican. Democrat is more blue, Republican is more red in this map over our state. So you see it's a inhomogeneous state. It's not the same everywhere. The statewide vote count really doesn't tell you what's going on. And then you look in each district and you decide who won the election by which person got the most votes in that district. And then we end up with these winners of our congressional race. And here I've put them up. So these are in that election, here are the 10 Republicans who won and the 3 Democrats who won. And the little people above is some symbolic representation of the actual vote count. Okay. So we have a little bit, who won, what the vote count was if you add it up just at the level of the precincts. Okay. Who won each precinct. So it's a lot more homogeneous than it looks, but this is the outcome of the election. And the fact is at the end of the day, it's the representatives we send to Washington, not the vote count. So it's who wins the seats that matters, not what the statewide vote count is. So let me go back to our vote count here. And I want to kind of play a game with you for a second. I want to say, like, let's switch. So here's one set of precincts that we used in 2016. Let's switch to another set of precincts. This is actually from the 538 blog that you may know. And it's a redistricting which is designed to be as nice to the Democrats as it possibly could be. And so let's play the same game. So let's now take each of these districts and let's use the same vote count that we had before. Let's add up all the votes in each of these districts and let's see who wins each district. So here we go. We have a number of winners now, different winners. And you'll see that unlike the previous one, we now have, I'm not so good at math, believe it or not, something like 8 Democrats winning, right? So 8 Democrats winning and 5 Republicans. So, a totally different outcome, right? Imagine, the political headlines the next day. 8 Democrats win. Democrats grab control of North Carolina. The previous one was 10 Republicans win. Resounding victory for the Republican Party. The fact is, we didn't change a single vote, right? This picture, this background of precinct level voting that we had never changed once between, all that changed was where we drew the districts. So let's think about this a little bit more. So here was the beginning idea that Christy Vaughn and I had. She was the undergrad who I did the initial work with. We asked, what if we drew these maps randomly without any nod to political agendas? And we just drew them in such a way that we just satisfied all the basic nonpartisan principles. And we'll get into that in a second. So we're going to draw a bunch of maps. So here actually, before we get going, here are 4 historical maps from North Carolina. 3 of them, the top 2 in the bottom left, are the ones that were used in the 2012 elections, the 2016 elections, and the ones that will be used in Tuesday's election in 2020. And then in the bottom right-hand corner was a bipartisan group, half Republican, half Democrat, retired judges in North Carolina, drew a map to show what would happen if you tried to do it in a bipartisan way instead of one party making all the decisions. And what if we had these 4 maps? So there are those 4 maps. What if we wanted to figure something out? We could try to compare these 4 maps to each other. But 4 is not a lot of maps. It might be useful to have a few more maps. So what if we had a way to draw a whole bunch of other maps that we could compare, right? And what if, we even drew more maps? So the basic idea that I want to explain to you is, what if we had a huge collection, an ensemble of maps? That's what we call a collection of maps. And then we use that as some way to create a baseline as to what would have happened if no one had used a political agenda to redistrict the state of North Carolina. And then if you have a map you care about, for instance, one of those 4 maps, we could compare the outcomes using those 4 maps relative to this collection of maps. So we're going to keep the votes constant, but we're going to change the redistricting and see what happens. So here's an example. So here I have map 1. So I'm going to go over a huge collection of maps, and we use the same votes in the bottom right-hand corner. And it turns out that they'll elect 3 Democrats and 10 Republicans. So we draw this little histogram and we put 3 over the number of Democrats. We draw a little bar there. Now we do another map, and this one elects 8 Democrats. And now we do another one. This one elects 6. So far it's like, well, what should have happened? We don't seem to see any pattern. We don't seem to see any structure because the votes are never changing. So we keep doing this. We keep doing this. And slowly but surely, we build up a little histogram here, which shows, let me just go back here, that shows over these first 9 maps in our collection, these were the different outcomes. Sometimes we elected 8 Democrats, sometimes we elected 3 Democrats, but we often elected 5 or 6 Democrats. And I emphasize that we're actually using real historical votes here. All right. In fact, when we did this analysis, this is related to the analysis we did in the case of Common Cause v. Rucho, which is one of the cases that went to the Supreme Court. We had an ensemble of about 24,000 maps. And when we did that, we created a histogram here. And this little arrow at 3 shows what happened with the map that we actually used in the 2016 election. And as you see, it's rather unusual. It's not at all the typical result. And if we took a different map, which for instance is the map we're going to use in the 2020 election, this is the outcome. So remedy was the map that the court forced this legislature to draw as a remedy to its previous map that was declared unconstitutional. And here are 2 other elections. So the 2012 and the 2016 elections. And here I have all 4 of those maps that I put out there. So the maps that we used in 2012 in North Carolina, the 2016, those are in orange and purple. And then this map that was produced in 2020, the remedy map, the remedial map, and the judges map that was this bipartisan collection of judges map. And the first thing you notice here is that we never changed the vote once. Every precinct voted the way it did. Now, we can have an argument about whether you think people change their vote dramatically depending on the candidate, but for a moment, let's just leave that alone. Let's just assume that each precinct votes the same way. And all we do is reorganize how the precincts are arranged. And you see we can go in 2012 from 4 Democrats elected to 9 Democrats elected. So it's a rather dramatic swing in the election outcome. And in 2016, of course, was a little bit more Republican year. And so 3 Democrats to 7 Democrats. But you also see that the remedial maps that the court forced the legislature to draw and these bipartisan maps that the judges made are much more representative in the sense that they show up right in the middle of this histogram. And so that's what our test is. Our test is, look, the problem is that when you want to think about what would have happened, it's hard to fall back on some abstract principles because the state is very complicated. North Carolina is this long tube of a state with mountains and beaches, with many small metropolitan, a few large metropolitan areas, relatively rural areas, farming areas, industrial areas. It's not so easy. So what we use is this collection of 24,000 maps, this experiment, to show what the structure of the state and the pattern of votes in that election might have produced or typically would have produced if we used a map that had no political agenda. And then one might then conclude that the maps from 2012 and 2016 were drawn with some political agenda, or at very least the people who drew them the onus should be put back on them and they should be forced to defend their decisions. All right.
Jonathan, this may be a question for tomorrow, but one person asked, how exactly did you come up with the ensemble of different maps?
Yeah, so I'll say a little bit about that. That's a mathematical question, but the short answer, well, I'll come to that in just a minute. It's a little bit later in the slides, but I will say as much of that as you might have liked, but I will say more about that tomorrow. But I'll be happy to answer any question in the Q&A about it. It's fine to interrupt if you ask questions. I'm happy. Otherwise, I feel like I'm talking to my cat. Okay, so part of the conversation here is not only figuring out what you think happened in a map, but also finding ways to convey this to the court. So one way that we actually found in the last trial that was very effective was to show the following movie. So let me set you up here a little bit. So I think you can see my pointer. So right here is the Democratic vote share. So I've created kind of an artificial set of votes, but that are based on the historical structure and patterns of voting in North Carolina that produces 42% Democrat statewide vote at the moment. And I'm going to slowly ratchet that up towards 55% Democratic votes. And I'm going to use this histogram of 24,000 maps. And this histogram is going to slowly move to the right as it becomes more and more Democratic, the vote. It's going to elect more Democrats. And this map here, this little arrow is going to show you where the map that we used in our elections in 2016, what outcome it would have produced. And so I want you to watch. So right now it's at like 44, now 45%, 46. It keeps going. It keeps going. You see, whoops, sorry. Darn it. I forgot. Sometimes it won't pause. Oh, I see. I can pause down here. Okay, very good. So here, I'm sorry, I'm doing that again. I blew it. So now it's going, you see right here, actually, we're almost at 50%. Let's go a little bit farther. There, we just passed 50%. And you notice that it's not yet electing 50%. It's somewhere in the middle. It's actually close to 50%, but it's still a little biased or a little tilted to the Republican Party. I would say it's not biased because that's just what happens in the state of North Carolina with that statewide vote fraction. But one thing you might have noticed is what the outcome of the enacted map has never changed. It's never moved. So in a way, this map was designed to be non-responsive to the changing will of the people. The voters change their votes, but that never changes the legislative outcome. All right, so let's keep going a little bit more. So here it goes. Now we're well above 50. All right, now finally it starts to move. And not until almost 55%, 56% Democrat does it actually move all the way over to the right. Does the map, enacted map. So I want you to watch it one more time. Watch this enacted map, how it lags tremendously behind responding to people's changing their opinion. And so whether you're a Republican or Democrat, I think that this is not democratic. The fact that you have maps that don't respond to changing political will. At the very least, elections should have consequences. All right, so let me show you another map. So this was a video we actually showed in court. One of our panelists was the lawyer who helped me present this to the court. And so now this is now the North Carolina House. So we have a bicameral legislature in North Carolina, a House and a Senate, just like at the federal level. 120 seats in our House. That's what the 120 is here. And now we're going to play the same game. So right here is the Democratic vote fraction, and it's going to slowly change. So we're going to watch it change. Here it goes. And right now it looks very good. That's right in the middle of the blue section, right in the middle of the ensemble, what the ensemble histogram predicts. But now let's watch it a little bit more. And now you notice, so this first dotted line is important because that's when the supermajority in North Carolina is broken. So right now, most of the ensemble maps would not give the supermajority to the Republican Party. But you notice the enacted map still gives the supermajority to the Republican Party. Now it finally stopped, but by the time it stopped, a fraction had already actually flipped the legislature to the Democrats. So now we're almost up to 55% Democrat, which never happens in North Carolina. We're a very purple state. We're always right around the middle. And only then does the most of the maps give the legislative control to the Democratic Party. But this enacted map kept it with the Republicans. And I should say that, there's a long history in North Carolina probably of gerrymandering. We don't have as good analysis of the earlier years, but probably a decade before, the Democrats probably did their best to keep control. Right? For 100 years, the Democrats kept control of the North Carolina legislature. All right, so now let's do this one last time and let's watch it. Now I've added one more map. That's the map that was replacing this map because of the court cases where this testimony was given. Now, I didn't draw that map. The legislature actually did, but they were forced to by the state. And you'll notice that this map does a much better job of tracking this moving set of blue histogram. All right, here it goes, slowly across. And you see it does so it lags a little right here, but in a minute it will pop across and switch the control of the legislature, even though the overturned map preserves it. Now this one goes a little bit farther. There it goes. All right. So that was using a slightly different set of votes than the original one that I showed you. So that's why it acted slightly differently. That was using the set of votes from the presidential election. So you could ask yourself, what if you used a whole bunch of different votes? And here is a histogram that shows that these little blue histograms are very much like the ones I just showed you. And the purple dots are what the legislature's map did. And the yellow dots are what the map that we replaced it with based on the court order. And you see the yellow dots tend to stay closer to the blue histogram. It's not perfect. It has some flaws still, but it does a much, much better job. Whereas the purple dots, in particular, whenever the Democrats were in danger of winning the majority, it dramatically under-elected Democrats, where this yellow dot is much closer to the histogram. Okay, so this is the story to tell you. Now, let me tell you a little bit. Now, here I'm answering the question that you asked me, Brendan, a little bit. So I kind of think of this as three parts. First, there's a part where we encode public policy and law in a distribution, in a probability distribution, in a mathematical distribution on the space of all possible redistrictings in North Carolina. That's a huge space. Then we use a Monte Carlo algorithm, and there's lots of ways. Another panel member here has a sequential Monte Carlo method, which looks very nice. Also, there's a lot of research now in thinking about how to improve these kind of algorithms. But we use the Markov chain Monte Carlo algorithm to sample this space of redistricting. So that's how we created these 24,000 maps. Then we have this problem of how do we understand what's going on and how do we effectively visualize and explain our results, all right? So the first thing is we create what's called a Gibbs measure. We have a score function which tells us how good or bad a particular redistricting is, whether we like it more or less. And there's some criteria which I'll talk about just for a second. And here's it's a very complicated and rough surface. This is a very hard mathematical problem that gives rise to a lot of interesting mathematics. And the things that go into this function J, this score function here, are things like compactness. We want the districts to be relatively compact. And the way we do that is we look at something that mathematicians would call the isoperimetric ratio of a surface, or the Polsby-Popper score for a political scientist. It's just the inverse of it. And it's the ratio of the perimeter squared to the area. And that's smallest when it's a circle. So it's smallest when it's a nice compact circle. And then we have some other things we have to include. So we always include population. We want the districts to have equal population, and that's to have one person, one vote. But we also, in North Carolina, for instance, we want to preserve counties and cities. We also want to comply to the Voting Rights Act to give minorities that have a large enough concentration a good chance of affecting at least the outcome in some of the districts. And in some places, you want to include ideas of community of interest. And so we put all this into our function J, and then we use that to draw districts. But you notice never in here did I put anything about political affiliation. I just used the geometry of the state and where the people live. All right. So this might be a good time to, if there's a question burning, Brendan. If not, I'll go on. So after we have this first thing, so I've given you this very coarse answer. I've said, here's how many seats would have been elected by one party or the other, given to one party or the other. But what we're really interested in, my title was Understanding Gerrymandering. So what we really want to do is we want to create a lens. When mathematics at its best, I think, creates a lens that you can look through and you can then understand what's going on. It simplifies, it focuses your attention on what's important. And then you can explain to someone, the court, the lawyers, the policymakers, what's going on. And hopefully then they can decide what's good and what's bad on their own right.
Oh, just one clarification. Yeah. So you're often fixing the votes, like people
always fixing
one set of votes.
Yep.
You're sort of varying over the different ways of drawing the districts, right?
Yes.
So a lot of people were thinking that, oh, are you like modeling different vote outcomes, but you're fixing the vote.
I'm fixing the vote. And I want to be really clear. I'm not in the business of predicting what would happen. I don't want to call any of this prediction. I think of that each of these is a probe. So here we actually have each of these ones is a different set of votes. North Carolina Secretary of State, 2016, U.S. House of Representatives, 2012, Governor, 2016, U.S. Senate, 2014, Presidential, 2012, Presidential, 2016. Each of these votes is a different probe that we can use to poke this redistricting to see how it would behave, right? It's a redistricting is not just a gerrymandering in one case, right? We saw that when those districts, when they were very Republican, they acted very normal. They acted quite representative. It was only when it became more Democrat that it caused a problem. And we see that right here. The governor 2012 was a more Republican election in North Carolina. This is the statewide Democratic vote fraction on the left-hand side. So this was 44% statewide Democratic vote share. So this one, all those maps actually behave rather reasonably. But we start to see that as it becomes more and more Democratic, it starts to act unreasonably. You might, that's a question for the court, for the public policy people. But I would submit that that's unreasonable, that over this wide switch. And each of these elections has different spatial patterns. Some of these elections, the suburbs of Raleigh voted one way and the urban core of Raleigh voted another way. In other elections, Raleigh voted like Charlotte. It's, it depends. And that's why these are all different probative, tools to kind of understand. All right, maybe I hope that answered the question a bit more. So the point of this slide was just to make the point that it's not proportional representation. If it was, then the center of those histograms would track right with this black line. And the fact that it's not says that we're not assuming proportionality here at all. In fact, we're revealing that our system tends to favor parties that are more geographically spread out. And so there is a kind of inherent tilt if you look at the statewide vote fraction towards the Republican Party. And that's just a fact of our system. If you don't like that, then we should have a different conversation about changing our system. But that's not the conversation I'm having right now. I'm having a conversation about, here's the rules of our system. What does it do? What does it predict? So we also did an analysis of Wisconsin at some point, and this is a much more complicated plot, but let me just unpack it ever so slightly. It asks, over our large collection of maps of Wisconsin, what vote fraction created a 50-50 split of the legislature? And you see for each of these different elections, these are 3 different spatial patterns of voting in Wisconsin that were actually historically true. It seemed to be around, here it's around 49% was enough to give a 50-50 split. So 49% Republicans, this is Republican vote now, gave 50-50 split. This one, it only needed 46%. And this one only needed 47% roughly, or 46.5%. But the point is that in all cases, this little arrow is the map that the legislature drew. Yes, there's a tilt towards the Republican Party, but the tilt is not explained by the fact that our system, that people tend to pack in cities who vote Democrat. It doesn't explain it. You can separate these 2 effects by using this tool. All right, so let me I'm diving slightly more into the weeds, and I'm not going to explain this whole picture. This was a picture a picture like this we actually showed in the Rucho case in the state trial, in the trial in our state, in the federal court. And the only thing I want you to pull out of this really is that this little box of histograms down the middle says how many Democrats we typically see in the most Democratic district right here, the second most Democratic, the third most Democratic, the fourth most Democratic. And the thing to notice is this orange plot here is the actual map, and it has unusually many Democrats here and abnormally few Democrats here. And it does it in the 2 maps do the same thing. And the thing to notice is the yellow map is the map that we got in the 2020 election. We'll use in the 2020 election based on the court order that Elizabeth and her team of lawyers were part of securing for my state. And, you see it acts much more, it still has a few issues. It's not perfect, but it has a lot, it's much improved over this very dramatic jump here. And this big jump here is actually what caused that zone of non-responsiveness where the election didn't change outcomes. So we actually have tools that we can go in and actually understand what's going on better. All right. And actually, so when you hear about cracking and packing, which is maybe a term you hear if you read in the press about gerrymandering, it's the idea of sticking Democrats or one party in a district they would have won, in this case, Democrats, and removing them from districts they might have almost won, but when you remove them, they lose. You crack them out. And this tool here can be used to identify cracking and packing. All right. I don't want to give you the idea that only one party does this. So here's an analysis of Maryland. So here's a bunch of maps that we created for Maryland. I really can't do this justice. There's a whole bunch of interesting mathematical questions when you have a huge body of water running through the middle of your state. But what I do want to point out to you is that we see the same kind of sticking phenomena. As if we take elections that slowly move to the more Republican side, the Democrats win the same number of seats always. So the Democrats have engineered this in a way to make sure that the Republicans never lose this seat. And it's a friendly gerrymandering. It's the 2 sides of the legislature getting together and making sure. So they basically rigged this so that the Republicans, it's almost impossible for them to lose this 1 seat. And in some elections, they almost lost it here, but they didn't. Where a lot of the maps I've drawn would have actually had the Republicans shut out completely of that legislative delegation. But, there's been a compromise probably at the state level where they made this kind of cracking and packing to preserve one Republican district in all cases. So both sides do this, and the upshot of that is that they made it almost impossible to lose the last Democratic district. So they almost always win 7. Okay. All right. So and this is an analysis that talks about this non-responsiveness. Is that, you know, I don't want to go into this, but the thrust of this analysis really is to say that over a large range of political outcomes, the Democrats always win 7 seats in Maryland. They never lose that 7th seat. So it seems to be gerrymandered to protect that 7th seat. And conversely, make sure that the Republicans always hold on to 1 seat, no matter what. All right, so let me just try to summarize this a little bit. Seem to be flying along. So let me just point out. So we're going to hear more about this. I really hope you'll take the chance to ask about these court cases in the Q&A part. You know, this was really, in all these cases, this right here was my first case that I was part of, which was Common Cause. No, that was not it. Here it is. Sorry, Common Cause versus Rucho. This is the brief that went to the Supreme Court. And we have a representative from Common Cause here. So they're the ones who actually brought me into this. This was a purely research project that I started with a bunch of undergraduates, and then they heard my talk and I ended up testifying in court. And then these are the later state cases that Elizabeth Theodore was part of, and hopefully we'll hear some from her in the Q&A part. And lastly, it's so close to the election, I can't help but just say, you know, a lot of people have worked very hard to make it so that, you know, in certain states and generally that the maps are responsive, right? That they try to respond to what people vote, whether you vote more Republican or more Democrat. So, you know, people are fighting hard to make your vote matter. So I do hope that everyone goes out and votes in the coming week, if you haven't already. So here's my last slide. So I finished a moment early, but let me just dwell on this for a second and point out, if you're from, you know, university, you might like to notice that all these people labeled with UG are undergraduates. So these are all undergraduate research team members who are part of various parts of this research in lots of different ways. There have been lots of parts of this. I'm only presenting the part that we did really for court cases in the end, or that ended up being useful. And here's some of my more theoretical collaborators, and some of these people are applied collaborators in the Triangle area. We have a group of people working there. So it's a whole crowd of people who've done a whole bunch of projects on this. And if you want to learn more, there's a website, which I think ICERM linked to, but it's our Quantifying Gerrymandering blog. And there we have a lot of short little, hopefully well-written pieces that describe various works we've done and various ideas. So lastly, I'll say thank you. And I can't resist the chance to play this movie as we finish. So you can watch this movie one more time. All right. Thank you very much for your attention, for all the people who showed up. And I really look forward to the conversation that follows and any questions that Brendan has. So
thank you very much. So there were actually a lot of wonderful questions about sampling and technical aspects of how to find the different maps.
I'm happy to say a little bit about that if you want.
I think my instinct is maybe to defer that until the more technical talk tomorrow. I think these are very interesting questions, but I'd like to stay focused on the aspects that touch on public policy. So I'm just